Alright, so today we're going to talk about Hamiltonian circuits by me, Brenda Kapani. So what is it? So they are circuits that go through every vertex of a shape or graph with no repeats, starting and ending at the same place. And if you're wondering who made it, it was made by William Rowan Hamilton in 1857 as a game. And originally, it was to find a Hamiltonian circuit in a dodecahedron. So you might ask, what's the purpose of it? So the purpose of a Hamiltonian circuit is to find the minimum cost Hamiltonian circuit, which means to find the path with the least total weight. And another way of calling a minimum cost Hamiltonian circuit is to name it a traveling salesman problem. This second name comes from the fact that a problem people often do with Hamiltonian circuits is to find where a traveling salesman should go, like what path they should take when visiting multiple places. So you might ask, how do you find a minimum cost Hamiltonian circuit? Well, there are three ways. The first way is called the brute force algorithm. And this is similar to like a guess and check method because the main objective is to, using whatever graph you get, is to find all the possible paths and then choose the one with the least total weight. And you find the total weight by adding up the individual edge weights. So to find the number of possible paths that could be in your graph, you take the number of vertices, you subtract one, and then you find the factorial of that. And whatever that number is, that's how many possible paths you have. So for this graph, there are 4 vertices. So you subtract 1, so 4 minus 1 is 3, and 3 factorial is 6. So after you find the number of possible paths, you actually have to write them out. So as you can see, there are 6 possible paths. Or 6 possible circuits, since we are starting and ending at the same place. And so we're going to always start from point A and end at point A. And you can see the 6 different combinations of what could be in between those, using all the other vertices. So after you do this, you're going to go ahead and add each individual edge weight that is in that line. So from A to B, it's 6, and then from B to C is 12, from C to D is 6, and then from D to A, it's 2. So that's 26. So then you do that for all of your possible circuits, and then whichever one is the lowest, that's your minimum cost Hamiltonian circuit. So after writing out each of the total edge weights for each of the possible circuits, you can see that the second one and the fourth one have the lowest edge weight of 22. So the nearest neighbor method is the second method you could use. So just as the name suggests, you start at one point and you go, and typically you choose the next lowest edge weight, and you keep going until you are back at your starting point. And this may not be the lowest edge weight possible combination, but it will be a Hamiltonian circuit. The third and final method is called the sorted edges algorithm. So using whatever graph you have, the first step is to write out from least to most the edge weights of each line. After that, using those lines, you find the best path or circuit that will take you from the start to end using the minimum edge weights. And it's basically like organizing what you have, and so you are making the best path choices. And as you can see, using the information that you have, you can find the minimum cost Hamiltonian circuit. So Hamiltonian circuits are more than just a game. For example, in cities, mailmen and people who travel between them have to choose the most efficient way possible to go from city to city without taking any extra miles and wasting any gas. Another example of this is telephone lines. They're connected all over the world, and we have to make sure that we are connecting them in the most efficient way possible. And lastly, with jobs and their applicants, Hamiltonian circuits are used to line up the best candidate with their job. Thank you so much for listening, and I hope you learned something about Hamiltonian circuits.